Hello and welcome to our Science Seminar Spectacular. Today we are going to take a look at the reasons as to why the orange-bellied parrot population decreased. Did the population decrease because of Claim 1, that the births decreased, or did it decrease because of Claim 2, the deaths increased? Stay tuned and keep watching. Get your evidence cards out and follow along with us as we go on the Science Seminar Spectacular.
Welcome to our science seminar. We are going to start with card I that Mr. Cranach is holding up for us. This is our orange-bellied parrot card. And on this card, scientists took some studies over 50 years and they discovered that the orange-bellied parrots have a layer of fat on their bodies, and that this is where most of the energy storage molecules are, and they store them. And that over 50 years, scientists analyzed the fat of the parrots that were collected at 3 locations near the west coast of the island. Scientists concluded that the fat on their bodies has decreased over 50 years. So the question we want to ask is, how does this play into our claims regarding the orange-bellied parrot population decrease? And so remember, we're looking at Claim 1, that the births decreased, or Claim 2, that the deaths increased. And so this card I, does anyone want to go first and just kind of see if it relates to their claim and how they can fit it in? Mrs. Reynolds, go ahead.
The claim that there was a lot of their food was present in the center of the island, that evidence seemed to be weak to me. So I might maintain that the if they had done more testing towards the south side of the island, that we would find that the birds had less energy storage molecule availability in terms of the buttonwillow grass.
So Mrs. Reynolds, you are referencing evidence card A that states that
Correct.
the button grass increased, but you're saying that maybe there wasn't enough research done in order to support that, and that could have caused the bursts to decrease.
Correct.
Orange-bellied parrots. Okay, Mr. Cranach, Mr. Vandegrift, do you have anything you'd like to add?
I think that's the thing I was looking at too, is where the button grass was located. And yes, it did increase over the period of time. However, as I was reading about the orange-bellied parrot, it did say that he migrates. So and I thought to myself, wow, that's very interesting. So he's having to really go get his food, because it didn't really show the button grass in the area where the orange-bellied parrots live most of the time. So yeah, they are moving. However, I think that's not the main reason why they weren't able to get the fat molecules and the energy storage molecules in order to reproduce. I think a lot of it had to do with the fact that increase in sparrow population, and also, maybe I'm getting ahead of myself here too, but the red foxes and the feral cat increased population too, and those are both are the consumer populations that go after these red orange-bellied parrots.
As the red fox population then increased, as red foxes are ground dwelling and the parrots do eat buttonwillow grass from the ground, that also could have caused the birds to defer from their preferred feeding grounds, which provided less buttonwillow energy storage molecules.
I'd kind of jump in here, and I would, getting back to, I think the evidence card I would politely like to disagree with my colleague, Dr. Reynolds. And I think that card I supports Claim 2 more. So I know Claim 1 is that the bursts decreased because they didn't have enough energy storage molecules. But I'm thinking what's even more essential than reproducing is just surviving. And so birds are warm-blooded, and the way that they need to stay warm is they fluff out their feathers and they trap a little layer of air, and then their body begins to warm up as they are breaking down and using the energy storage molecules. They use their muscles to kind of shiver and stay warm. So I'm thinking if the fat layer is decreased, then their availability of these energy storage molecules within their body is decreased. And if there was a really extra cold winter, or they had to fly to migrate to Australia, again, they might not make it. They might not have enough energy storage molecules to fly. And as some of the researchers showed, that they might not make it. And so I think that that thin layer, that decrease in the fat and ice supports claim 2 a little more than claim 1.
Well, I feel like we're also there, we're not looking at all of our evidence, and that we can maybe look at a few more pieces of evidence to come to a maybe a more of a consensus. And so one of the pieces of evidence I would like to look at is evidence card E, the sparrowhawks, and how this population, this is actually a really good evidence card, and I'll hold it up here. You can see they actually took samples from 8 different locations. So we know this is a really strong piece of evidence. And what scientists found out is that the collared sparrowhawks, well, they decreased. Well, according to our food web, which I have right here, if our sparrowhawks decrease, that means our sparrows could increase. And if there's more sparrows running around, they're eating more button grass. Now, yes, we do have the evidence card with the button grass from the one sample that says it did increase. However, I believe that this is a weak piece of evidence because it was only taken in one location at one part of the island. And so I would come to the conclusion that the button grass actually possibly decreased, and that meant that there was less energy storage molecules for the parrots, which means they didn't have the ability to reproduce as easily. So that being said, that helps to support claim 1, that the bursts actually decreased. But I am curious about one piece of evidence. We haven't talked yet about the Tasmanian devils. Did that piece of evidence have anything to do with either the bursts decreasing or our deaths increasing? Would anyone like to weigh in on that?
Food web, Tasmanian devils. I honestly, it's interesting. I didn't even. Those cards are over there for me. I didn't view that as anything that was important here. They're going after long-nosed potaroos. Tasmanian devils and red foxes both eat those, but the Tasmanian devil population decreased. So I didn't really see that as anything at all, anything to do with the death increase in orange-bellied parrots. I don't see the correlation there at all.
So let me.
Well, I would like to disagree with my my peer, Dr. Cranock. The fact that the Tasmanian devils decreased would cause the potaroo population to increase, thus causing greater births in the red fox population, which the red fox is a direct predator of the parrot, causing less births than in the parrot
Less
population.
birds. So that Dr. Reynolds, I believe that.
Oh, and not only does the red fox prey upon and eat the orange-bellied parrot, the feral cat does. So the orange-bellied parrot in actuality has 2 predators causing that could gobble them up, causing less births.
So kind of just reviewing, I want to just review what my colleague said here on evidence card. What is that? Is that F? That's the Tasmanian devil. Again, I think we would all agree that this is a super strong piece of evidence. So I give it a thumbs up and a big smiley face because it's 10 sites where they were sampling the population. So again, I'm just thinking, man, maybe people love Tasmanian devils and they have a lot of resources and a lot of people have donated money because it takes money to research. So it's a very strong piece of evidence. We do know over the last 50 years that they've decreased. As you can see here, it's decreasing. What was really interesting is it plateaus right here for about 10 years, from the 70s to the 80s. And that's 10 years where it just maintains stability, and then it continues to drop again. So what is causing this population to drop? I don't know. That's a whole nother investigative question. But we do know this is a strong piece of evidence. If the Tasmanian devil population goes down, their main resource population is the long-nosed potoroos. So we know that if they're not feeding on them, then those potoroos population is going to go up. We also know that that long-nosed potoroos is a resource population for the red fox. So now the red fox is the consumer population is going to go ahead and feed upon them, get more energy storage molecules, have more births in the red fox population, which is going to increase their population, which I do believe on card C kind of gives some evidence for that, although it's moderate because the sample size was much smaller. But that does, and then if they have increased, then that's going to be more of a threat to the orange belly parrot, because now there's more foxes to feed upon them. And that would support claim 2, which would increase the deaths. The population would decrease by an increase of deaths in the orange belly parrots.
So,
Orange belly parrots. Orange belly parrots. Say that 10 times.
Mr. Vandegrift, I would like to address something in your argument, if that's okay.
Yes, which part are we talking about?
Well, you're making the case that the Tasmanian devils, if they decrease, that the long-nosed potorous population would increase, and that could lead to an increase in the red fox population. Is that correct?
Correct.
Okay.
Because Tasmanian devils only feed, according to this food web, on the long-nosed potoroos.
Okay. The only thing that I have to say to that is that in actuality, we don't have any data to back up the case as to whether or not the long-nosed potorous population increased. We can make an assumption and we can make an educated guess, but we don't have any data that says for sure. In addition, just because the red fox population increases, which we do have data to say, or mild data to say that it increases, it doesn't necessarily mean that they're going to go after all of the parrots. They could primarily still feast upon the long-nosed potorous. And again, we don't have evidence to know, did that population really go up? Is it going down? So I feel like that's a weak connection, or could be a weak connection as far as supporting the claim that the deaths increased in the orange-bellied parrot population.
My question to my two colleagues that are claiming number 1, births decreased. What is your, give me 1, 2, 3, 4 reasons why that you guys believe that the births decreased. Tell me why.
I'll begin. As you stated earlier, the sparrowhawk population decreased. The strongest piece of evidence then would be card E, where the sparrowhawks decreased all over the island, and that led to an increase in the sparrows, which are direct competitors to the for the button willowgrass for the parrot. The button willowgrass evidence, although it says it increased in a 50-year period, the evidence card A shows one location where the button willowgrass was actually, the evidence was gathered, and that's sort of a weak evidence. I would like to see that piece of evidence looking much like the Tasmanian devil evidence, where there are 10 locations of evidence. So I still maintain that the parrot is not gaining enough ESMs due to competition with the sparrow, direct competition with the sparrow for energy storage molecules for the button willowgrass.
And I would like to add into that we have evidence card I that shows that the fat decreased on the parrots. And so again, we can go back and forth as to what that could have caused the parrots to what effect that could have had on the parrots. But from our point of view, we say that that would support the idea that they didn't have enough energy storage molecules, and therefore they weren't able to reproduce as much.
Getting back to Dr. DeMeyer's point that we don't have any evidence for the long-nosed potoroos, who are they, for whatever reason, And I can see that the red fox, they will either use the parrots as a resource population or the long-nosed potterus as a population. So I would agree with that. But if we're trying to follow the strongest piece of evidence, I'm looking here for claim 1. Your strongest piece of evidence is the sparrowhawks. And I think you have 8 locations, and I can see how that supports your claim that if the sparrowhawks decrease, then there's going to be more sparrows. More sparrows are going to eat more of the button grass, less button grass that's available for the parrots, and thus they're going to have less energy storage molecules and less births. I see that. But if we're going to go with the strongest piece of evidence, we've got to come back to the Tasmanian devil card, which has 10 sample sizes. And we know everything in science is about sample size. The more that you can do, then the stronger that is, and you're going to get a better, evidence criteria, you're going to get a better idea of the whole population. So what I would say is if we follow the evidence, that this would support that something, it is leaning towards the foxes increasing and them eating more of the parrots, with this being the strongest piece of evidence out of all of our evidence that we have. Second, I think that would be a good reason to go out and try to get funding for the long-nosed potterus, and then start to do some samples with that to see if it lines up and strengthens our case or weakens it. Because again, remember, we're not trying to be right or wrong. We want to follow where the evidence goes. And so right now, Dr. Cranock and I are really believing that claim 2 is kind of the best choice right now. We've heard some of your claims, or your claims. And I'd like to have further discussion if you'd like, but that's kind of my stance.
I have one question for you, for Dr. Vandegrift and Dr. Cranock. How does evidence card I relate to your stronger piece of evidence with the Tasmanian devils? How do you tie that piece of evidence in to your claim?
Good question. Thank you.
Right. So what we're saying is this, that we have to look at all the evidence. So what we do is we have the strongest piece of evidence. So that gives us kind of the edge of pointing it to claim 2. So with that, we interpret this piece of evidence from that first piece of evidence. And we'd also say that, again, you need to survive before you can reproduce. You've got to migrate to the mainland to get away from the winter. And if you don't have those energy storage molecules, so that's just, it's building, it's just accumulating. I don't know if there's, and again, I'd have to give it some more thought and look through the food web to see, but I don't know if there is a direct, as more of it's in a supporting role. So I is just a supporting piece of evidence that supports our stronger piece of evidence with the Tasmanian devil.
So I feel like we've all stated our cases pretty well using our evidence, and we all feel some evidence is stronger, some evidence is weaker, some evidence takes us maybe in different directions than I thought it would take in. I'd like to take a minute before we close is just go around and just state maybe one thing that you learned differently, or one thing that it changed your thinking. In other words, like you came in thinking that this piece of evidence I had to mean this, but then after we all talked and discussed, you realized, oh wait, it could mean something different that I didn't realize. Do you have anything like that, Mr.
I'll start off with, I think originally when I saw the evidence cards that had no data at all, I just put those to the side. I didn't even consider them. But then when I was annotating the food web, I didn't really give it much thought. I just put this, there's no evidence here, and just moved on with the evidence that I had. So Dr. DeMyers gave me some thoughts of like, okay, so there is no evidence for the potterus population to go up. I'm just assuming that because of the Tasmanian devil being the strongest. So that kind of challenged my thinking in a way that I wasn't thinking of before. So it helped me come to a better understanding of where there might be a weakness in the argument.
No, I was gonna say one thing that caused my thinking to change was just the analysis and the thinking through the pharaoh cats and the foxes and what that meant for the orange-bellied parrots, as far as even the cats hunting them, or the parrots maybe, being able to keep a lookout and maybe not going down into the grass as often. So that was something that I hadn't thought of up until this conversation. Go ahead, Dr. Cranock, what were you going to say?
No, I was just going to say, you guys, this piece of evidence right over the button grass, and Dr. Reynolds was stating there really isn't, well, I definitely would want to have more data here as far as where all that button grass went. If it did increase, but is this the only place that it's located in Tasmania? Is this it? And that definitely opened my eyes quite a bit. I just was assuming that the orange-bellied parrot's getting there to get the food.
Mm-hmm.
I'd like to say that the bit of evidence that I learned something new from Dr. Vandegrift was I hadn't considered the migratory pattern of the parrot. I hadn't considered that if there were weather changes, I would love to know what the weather was over the 50 years and see a graph of the temperature changes for the birds. Needing to warm themselves up, that's a very valid point, and I think that it's worth looking into some weather data over that 50 years, and climate change, which is a big deal.
Can I say one last thing?
Yes, of course.
I think when you do an investigation like this and we're looking at all the data, it just brings up so many other questions.
It does.
What were the plateaus about? What was going on there? And again, our strongest piece of evidence is the Tasmanian devil card. And I'm like, well, what's causing them? What is causing their population to decrease? Is it some type of poison? Is it the pet trade and someone wants them as a cuddly pet? Probably not. But is it habitat loss? What's going on? So, but again, where's the evidence for that and why? So it just opens up other questions that I wasn't really thinking about.
So, Mr. Vander, if I hear you saying that there might be some outside factors that could cause populations to increase or decrease, or births or deaths to increase or decrease, that are outside of a food web.
Right. I think just through looking at evidence and studying, it seems a lot of times that humans are pretty good at throwing things out of whack. So a lot of times I know that humans can affect the biodiversity of an area, as long as, even when it comes to fishing, we need our energy storage molecules to reproduce, to stay alive, to do the things that we do. But again, we've had issues with overfishing in the past, and that was getting back to our moon jellies. And we saw that with the sardines, right? And the indirect effect. So again, that's why it's important that some of these laws are passed so we don't overfish our oceans, because it's just unsustainable. So again, I do think humans have a big impact being at the top of the food pyramid, and there's a lot of just for our survival, but also moral obligation. Like, hey, are there other alternatives that are better choices for the biosphere and our ecosystem?
Okay. Well, I just want to say thank you very much to everybody. I know we pretty much have to go, so thank you again, and awesome job. Woohoo! Bye.
And that, ladies and gentlemen, wraps up our Science Seminar Spectacular. Who do you think did a better job of supporting their claims with evidence? Do you think that the claim that the births decreased and that caused the orange-bellied parrot population to decrease was the winner? Or do you think it was claim number 2 that the deaths increased and that caused the orange-bellied parrot population to decrease? Make sure you have your notes handy, and you can use all the evidence and your counter arguments in this to write your argument for tomorrow's assignment. Again, thanks for joining us for our Science Seminar Spectacular.